Well, good afternoon. It's afternoon now. My name is Suzanne Kemtrip, and I'm Chief Operating Officer for SoilMetrix. I have over 20 years of industry experience in ag tech, primarily 15 years of that with Monsanto, where I ran a lot of field trials. And walking those field trials in different geographies, I realized there's a whole lot more to emergence and yield than just the genetics of the seed. Soil has a lot to do with what happens at the end of the year, and that's why I'm passionate about working with SoilMetrix. At SoilMetrix, we enable farmers to manage their most critical asset, which is soil. And we do this by trying to, in the long run, eliminate that physical soil sampling by doing virtual soil sampling. And I'll talk to you here about what that means. In the development of our product, we've spoken with a lot of farmers and we've spoken with a lot of consultants. And they talk about how important soil is to the management of their farm and how digital soil maps, which is what we are developing, would really be a great boon to their efficiency on their farm. And do I really need to put this slide up here for you? We all know fertilizer is expensive. It's a problem. And there's continued regulatory pressure on the fields. And carbon market opportunities also require carbon quantification. So these are the three items that we feel like our product is addressing. So what does our solution look like? This is one iteration of our solution. And what it is a nutrient zone map that's delivered to the farmer or to the farmer's trusted advisor directly to their computer or through an application such as My John Deere or FieldView. And this particular image, which is a little red on this image, but we're looking at percent organic matter. And just by entering your field area, and we can look at 8 different nutrients, which I'll talk about in a moment, and get that delivered directly to your computer on your platform. And you can see actually changes over years too, because it happens a lot that, yeah, you may have changed some of the practices on your farm last year. Well, did that make a difference? What happened 3 years ago? So you can see actually the change over time as well of what you've been doing on your farm. So how do we do this? How do we achieve this? What we are doing is we're using remote sensing technologies as well as other data layers. So satellite imagery, LiDAR, and other proprietary data layers that we put together with artificial intelligence, machine learning, to make these predictive models to deliver these zone maps to your field. So what I'm depicting here are, say, for example, potassium zones and phosphorus zones. Let's see. You know, one of the questions is, does that work? How do we know that it really works? How do we know that those zones are really real? Well, we are using real ground truth data from soil samples obtained by farmers such as yourself to test our models and validate our models and develop our models. So this is the only data slide I'm going to show you, but what I have here are ppm of phosphorus, we have pH, percent organic matter, and potassium. And on the x-axis there are the actual values, the real values that come in the soil samples. And on the y-axis is our predicted values. And you can see our models are really quite close, that what we predict are really quite close to actual. So we intend to reach our farmer customers through the network, directly to the farmer, or primarily through the network of their trusted advisors. So our SoilMetrix app is accessed through that farmer ecosystem on a platform I mentioned earlier, either as a standalone system or as on something like My John Deere or FieldView or other similar platforms. So right now, it costs something like $16 to $18 to do per acre to do these kinds of grid soil samples every year, maybe, or every 3 years. But we intend to be charging $2 an acre. It comes up to something like an 88% cost savings to use SoilMetrix map as opposed to using traditional soil sampling. In addition, the spatial resolution, since we're using satellite imagery, and this is only getting better as satellites are getting higher resolution, our spatial resolution is 100-fold higher than current soil maps. And then our turnaround time is going to be in a matter of minutes as opposed to 2 to 3 weeks. You enter in your field area, and 2 to 3 minutes later, you see the soil fertility maps. So currently, we have pilot growers in our focus regions, which is the Memphis, Mississippi region, as well as the North Carolina coastal plain. And it's been really beneficial working with Ag Launch to tap into their farmer network to do this. So our IP, the base of our intellectual property, comes from North Carolina State University as well as Iowa State University, and then we have added to it with the development of these algorithms. So these are really well-known agricultural universities, and the original developers of this technology are still working with us today. So, and this is our team. We have over 80 years of combined experience in software architecture, soil science, and remote sensing. So Jim Reed is our CEO. I'm CEO up there. Julianne Bielski, who drove a lot of that technology development that we saw, she's currently with Google at this point, but still remains with us as an advisor. We have a really good collaborative relationship with a company called SAS, which is an international statistics analytical software company. And they are getting into ag, and they see the benefits of working with an ag company such as us and testing their analytical software. And there's together, we're seeing some really great results developing our soil maps. We are part of the Ag Tech Inventures portfolio. Ag Tech Inventures is a company that looks at early stage technologies within the universities and helps to spin them up into independent companies. So we're differentiated in the marketplace because we are looking at 8 soil components. There are some remote sensing, well, proximal sensing companies out there that are looking at these kinds of soil maps, but they're not looking at all of the components that we're looking at. So we're looking at phosphorus, potassium, calcium, magnesium, sulfur, pH, soil organic matter, and percent CEC. These are all the things that come back in your soil reports. Eventually, we'll give you the soil, it comes with the analysis, so what your medium and mean of that area is. The resolution is high. We are eventually getting to fertility prescriptions, so that if you get, if you're at this particular range in phosphorus, what our prescriptions would be for that. And it's a fully automated ecosystem. Basically, you enter in your area, and then the output comes back. We intend to charge $2 an acre for some of the first soil components that we come out with, and then would be additional charges for some of the newer and the next components that we come out with. We are intending to do an early launch here in 2022, so we are going to be looking for beta testers to have a look at the maps on their field to say, yeah, does that jibe with what your understanding is? And then we'll, in the subsequent years, expand out to more geographies and more crop areas. So since we've started, we have filed IP on our technology. We have participated in various customer discovery programs, had the opportunity here this year to join Ag Launch and this farmer network, so it's been really productive that way. We're looking to raise money, as well as looking especially for more data to help validate our models, as well as beta testers for our pilot areas. So if you would like to join us and you're really tired of doing physical soil sampling, come out and talk to us over at the booth in Ag Launch. And thank you for your attention.